Hey, what's up everyone? My name is Cody Engel, and in this video, we are going to talk about 20 controversial programming opinions. Before we do that, if you just wouldn't mind smashing the like button, it helps the YouTube algorithm. Other than that, let's just dive into this and start reacting. So the first opinion is programmers who don't code in their spare time for fun never become as good as those that do. No, I mean, it really kind of depends on why you're getting into the programming industry and kind of how you want to measure as good as those that do or don't. So I will program in my spare time for fun when I feel like it. It's something that I do enjoy doing, but it's not something that I'm out there constantly putting up pull requests and all of that. I guess in some ways, yes. I guess if you program in your spare time, it does allow you to practice more and it allows you to get a little bit more experience outside of the workplace. But on the other hand, I mean, I know plenty of programmers who are successful that don't program outside of work. If you're just starting out and you have no experience, you probably should do it in your spare time because you probably don't have a job to get that experience. But yeah, all right. So opinion number 2. So unit testing won't help you write good code. This one is just not at all accurate. And they kind of go in and like what they say is that the only reason to have unit tests is make sure that your code already works, doesn't break. So no. So there's this thing called test-driven development. Essentially what you do is you're thinking about what problem are you trying to solve. You're doing just like a calculator and you want to make sure that the calculator adds numbers correctly. You may start off with, 1 plus 1, when I put this into a function, it should return 2. And so you would write your code and maybe you'll just hard code the return value to be 2. But then you're like, all right, well, it adds 1 and 1 together. Now it has to add 2 and 2 together. And so you update the function. Now it may actually add the numbers together instead of just returning 2. When you do test-driven development and when you do it well, essentially what you're doing is you are coming up with a bunch of assumptions on how the program should work and you're encapsulating that into unit tests. And then at the time that you want to make those tests pass, you update the function or the class or whatever you're writing your code in. You update that so then it passes. Another benefit when you're actually doing test-driven development and just unit testing correctly is when a bug comes in, when something unforeseen happens, you can look at logs, you can figure out, okay, it looks like this was in this state and it caused it to do this. And so from there, once you have that test suite already available, you just have to plug in that state, see what you get, and then resolve the bug by writing the test that makes it fail, and then making that test pass. So the next one, the only best practice you should be using all the time is use your brain. And they go on and they say too many people jumping on too many bandwagons and trying to force methods, patterns, frameworks, etc. onto things that don't warrant them. Just because something is new or because someone respected has an opinion doesn't mean it fits all. Yeah, so the parts that I agree with in terms of just use your brain, essentially what you're trying to do when you're programming is you're trying to solve a problem. And so if you try to solve the problem by looking for, well, what pattern will solve this problem, you're you're removing the creativity from it. 2, you may not even know that the pattern exists. And so if you don't know the pattern exists, you're just going to spin your wheels trying to find, well, what pattern will actually solve this? When in actuality, most of the time, just go write the code. And this is what I do. I will write the code in the way that I think makes sense. And then I will go back and look and see, okay, does any of this fit into a specific pattern, into a specific design pattern or whatever? There are times at this point in my career where I go, okay, I need to build something. I need a class that just creates things. And so for that, I'll just be like, all right, factory pattern. I don't even have to think, I just know that's worked really well in the past, I'm just going to use that. On the other hand, if I'm just trying to encapsulate some business logic, I know, there's an interactor pattern, which you can call use cases, but does it have to be there? Could it be in a domain model? Can it be somewhere else? And so, yeah, I really like this one because you don't get hung up on trying to use the best pattern. solve the problem, and then go back and look and see, does it fit into a pattern? And then maybe refactor the code if you want to, where it like fits into that pattern. Don't feel like you need to find every single pattern out there. So the next one, most comments in code are in fact pernicious, are a pernicious form of code duplication. It's a big paragraph. I'm not going to like read through it all, but essentially they're talking about like you should concentrate on making your code readable and easy to understand just by looking at the code. And I agree with this in that sense. So in general, when I'm writing code, and actually one of the things in my career that helped me out the best was when I worked with an engineer that was like, hey, you should just don't even comment your code. It should all just be self-documenting. And I was like, whoa, that's weird. My instructor never told me to not write comments. Like that's what you do, right? But actually what happens when you write self-documenting code is it forces you to think about, okay, what scope am I in? You know, is this a class? Is this a function? Is this just a global variable maybe? And then from there you can think, well, like what variable name might make sense to hold this information? What function name makes sense for what this is doing? What class name makes sense? And so you're thinking all about that. And if you're writing your code well in a way where it's self-documenting and it just makes sense when you read it from, you know, line 1 down to line 50, you know, your entire class makes sense. That's self-documenting code. When you start adding comments on that, you're just really duplicating things. You're just duplicating what it does. You're putting the burden on the person who comes after you that modifies the class, because inevitably the class will probably be modified. If there's comments everywhere, you have to update those comments. Otherwise, those comments don't make sense anymore. I will say though, if you are writing like a library that is intended for other people to consume, where like they don't need to look at the inner workings of the thing you're writing, you should document that. And sometimes when you actually write documentation for like a class and a function, you may find out that as you are trying to describe what it is doing, you may realize this doesn't make sense. Why did I do it this way? And as you're writing it out, you may be like, all right, I'm just gonna actually change this. I've done this a couple of times, so that's why I call that out. But yeah, in general, like comments in code aren't really worthwhile. If you want me to make a longer video about how to write software without commenting code and just different techniques you can use that will give you the same exact benefit without the clutter, let me know. I would be happy to do a follow-up video for that. So next up, Googling it is okay. And they like, I'll probably just like show a screenshot of it, but it's a huge paragraph. So I'm not gonna read through that. In terms of Googling it being okay, yeah, it is. I will say it kind of depends on how long you've been in the industry in terms of how much you'll probably be Googling things. When I was first starting out, I used Google probably 75% of the time, maybe 90%. It was a lot of the time. And now at this point, so I've been doing Android development since 2011. I kind of know how a lot of things are working with it. I still do Google things at this point in time, but it's become less and less. But when I'm learning a new language, like say Golang or something like that, I go right back. I'm Googling. So don't feel bad if you're Googling stuff, because everyone does it, and that's just the nature of the job. Next one, so not all programmers are created equal. And this one I'm gonna read the paragraph because there's a bit more to it. And so they say, quite often managers think developer A equals developer B simply because they have the same level of experience and so on. In actual fact, the performance of one developer can be 10x or even 100x that of another. It's politically risky to talk about it, but sometimes I feel like pointing out that even though several team members may appear to be equal in skill, it's not always the case. So essentially, you know, developers, so if we're just talking about at the same skill level, they will still have different things that they are good at. Like one developer may be good with reaching out to people and speaking with people and, you know, setting up meetings, making sure that everyone's on the same page, talking about things and all of that. Whereas another developer may be very good at just like jumping in, doing things all by themselves. But then they may struggle when they need to pull people in and get help and work with others and collaborate and all of that. You may, like, another thing is like, you can't just say like, you know, a developer who, like myself, so an Android developer. I work really well when it's like working on like the repository layer, working on, just like setting up a project where it's maintainable and you can write tests for it. It's easy to just work with. I'm not so great when it comes to working with like UI elements. I don't really consider myself much of a front-end engineer. I enjoy working with it, but it's not my specialty. And so what I found that's worked out well is, leaning into that. Like if I'm working with another Android developer who enjoys working with front-end stuff, I may be like, hey, you take the entire thing there, I'll take all of this stuff, and then like we can sync up and we can work and all of that. But yeah, not all programmers are created equal, although I would hesitate from using 10x and 100x, because I would say no one is like 10x or 100x of another person. But anyway, number 7. So I fail to understand why people think that Java is absolutely the best first programming language to be taught in universities. So I think this article is a little dated. I will say Java would not be a good first programming language, although I don't think it really is a first programming language anymore. I think at this point you're looking at like Python as being a first programming language, which makes a lot more sense. You just kind of can read it easier. It just makes, I don't know. I haven't done a ton of Python work, but whenever I've had to jump into Python, it just makes a bit more sense. It's just kind of, it's easy to pick up and learn. Yeah, but then, so kind of like going back to Java, like even when I was getting started in taking computer science courses and stuff, Java wasn't like the first language I learned. The first language I worked with was PHP. Then in university, my like CS 101 class, that was learning C++, which I think that's actually not a terrible first programming language, just because there's not a lot of real like rigid constructs around things. It can be confusing when you like hit when you get into like bugs and like all of that. But I think just because you can kind of just like have one single main function and it just all works. Like I think C++, I think that's an okay first programming language. Java, I don't think that's a good one, just because it is heavily object-oriented. Object-oriented programming is not easy to pick up as like a beginner. So you probably want to shy away from a language that's like heavily object-oriented programming as your first language. That being said, Java is a great language to learn. It's a great one to understand. It's a lot of places. Even though it's not a good first programming language, it's a good like second programming language if you don't want to learn something like, say, Kotlin, but I digress. Number 8, if you only know one language, no matter how well you know it, you're not a great programmer. This article came out a while ago, so I'm hoping that we would, the way that they phrase these opinions may have changed. So I would kind of revise this to almost be, if you only know one language, no matter how well you know it, you may struggle. I don't know, just something. Because I know, again, plenty of people who may only know, say, JavaScript, or they may only know PHP. They do perfectly well. One area where you will struggle with, if you only know one language, is you only know one way of solving that problem. You only know, like, for JavaScript, you only know the JavaScript way of solving this thing. Whereas if you know JavaScript along with, say, maybe like Kotlin or Go or PHP or Java, C, C#, any of those languages, you're going to have a better idea of like, well, how would I solve this in this language? And sometimes understanding how you would solve it in one language will help you write better code in another language. Not only that, but it's really helpful, like from a job standpoint, to be able to talk about more than just one programming language. So if you can only talk about one language, you're kind of just like pigeonholing yourself into a single area of technology, which can be a little rough. Not to say that you need to be an expert in a wide variety of languages. So for myself, I am trying to become an expert with Kotlin. I would say I'm still a ways off, but that's the language that I really focus on. But I also take time to learn things like Go. I've used Java in the past, I've used PHP in the past, I've used JavaScript in the past, I've used C# in the past. None of those like 5 languages that I just called off, I wouldn't say that I would be very competent in working with them today. I can definitely make them work, but I've still used them. I still understand like how they were working and all of that. Number 9, it's okay to write garbage code once in a while. Yes. I think it's actually relieving to write garbage code, especially if you are coming from a pretty rigorous engineering environment where, say, it's 100% test-driven development all the time. It can be really nice when you just write some code that doesn't have unit tests around it, where you just write code where it does one thing really well, even though if you're gonna like pass in a parameter, like an invalid parameter, or like, not an invalid one, but just you pass in a parameter and it'll blow everything up. And you just know, well, I'm never gonna pass in that parameter. It's really nice. And another thing is when you write like garbage code, it kind of frees you up to be a little bit more creative with things. If you're like writing really like production ready code, it may end up falling into a lot of just like general design patterns and stuff like that. And that's fine. But yeah, it's great to write garbage code once in a while. So yeah, I agree. Also, it can be a little bit quicker too. So like if it only has to do one thing well, sometimes it's not the end of the world to write that like bad code. Just do it. Next up, number 10. So print statements are a valid way to debug code. Yes. I would say maybe not print statements necessarily. Yes, print statements are fine. What I would almost say is like just writing logs is a really good way to debug your code. And not only that, but you're debugging the code for everyone else who uses that in the future. So in the past, like from my Android background, Android Studio has a really good debugger. And so that kind of made me shy away from like using logs and, logging just different information that would have been useful during development. In the last year or so, I found myself going back to trying to log more stuff. And yeah, what is beneficial about that when you're just logging more information is you don't have to set the debugger. You don't have to worry about setting breakpoints and all of that. As long as each function has appropriate logs, if something doesn't work correctly, you just look at the logs and you go, oh, aha, that is why. Maybe it's like that function isn't being called, or the functions are being called in the wrong order. Yes, I would maybe say if you can avoid print statements, don't use print statements, but use logs, which is essentially the same thing as print statements, only a little bit nicer because you can like funnel those into third-party logging tools, and then in production you have more information. And yeah. Number 11, your job is to put yourself out of work. This is, yes, I agree with this one. It's a really big wall of text, so in the editing process I will just include that. Putting yourself out of work should be the goal of pretty much anyone, anywhere, because what you're trying to do, and what this is getting at, is when you are working well, when you're writing good code, it should be easier for another person to come in, work on that code, update that code. Ideally, the maintenance cost is less than the production cost. Ideally, it's easier to add new things into that and hook into that. And so yeah, ideally, the more that you're working, the less you would have to do. But what ends up happening is you end up you write good code, you would end up theoretically having to do less work, but it frees you up to pick up more work. And so because you can now pick up more work and you can do more things, instead of putting yourself out of a job, you're usually like setting yourself up for a promotion. And it's true for everything else too. Like if you're getting into management, again, your job should be empowering your team so your team can do as much work as possible without your help, because then as a manager, it frees you up to do more things. And yeah, so I agree. I think the other one that I would call out is making sure everyone knows how things work. So one of the jobs that I left in the past, when I put in my 2 weeks notice, I think I helped people for 2 days, and then that was it. Like, I mean, I still stayed for the rest of the time, but I wasn't doing anything really, because throughout the entire time I was there, I was setting everyone up so they can do the job without me. And so yeah, like just do good work. Do work that'll put yourself out of a job, because it probably won't. It'll probably be better for you. Number 12, getters and setters are highly overused. I'm going to read this one. So I've seen millions of people claiming that public fields are evil, so they make them private and provide getters and setters for all of them. I believe this is almost identical to making the fields public, maybe a bit different if you're using threads, or if your accessors have business presentation logic. I'm not in favor of public fields, but against making getter, setter for every one of them. Yeah, I mean, I would say like in the context of this, where you're just kind of creating getters and setters for the heck of it. Yeah, don't do that. Just don't do that. In general, the benefit of having specific like getters and setters is from a get function. You may have to do some background processing. So maybe the get function is actually going to set the value, and if it wasn't already set, it'll like set it once. For a setter, maybe you want to log some information. Maybe you want to do some validation beforehand. And one thing I've noticed is with a lot of like more modern languages, thinking like C# and Kotlin, specifically, where you can have getters and setters like overridden. Like so by default, you would have public properties, but if you want to update those to then have some logic in the get or the set functionality of it, you can override that, but it still just looks like a public property. So I would agree, but I would say like, getters and setters still have their place. And in general, like with more modern languages, you're probably still going to use them, but they're going to just look like public properties when in fact they're just, they're a little bit different. Next up, SQL is code. Treat it as such. Yeah. Yeah. When I think of this, when they like talk about that, they're talking about like sloppy, free formatted SQL code and just unmaintainable stuff. And yeah, I agree with this. In one project that I worked on more recently, we were able to find a way to test our SQL in just unit tests. And so for Android, traditionally you'd have to use an emulator to do that, but through a third-party library, SQL Delight, it allows you to like override the driver. And so instead of using the Android driver for unit tests, we can use an in-memory driver. And so that allowed us to just, essentially just like write out a test of, I expect given this set of data, when I run this function, I should get this set of data back. And so that was kind of helpful, just like treating it as code in that sense of having unit tests. The other one, like for formatting, yeah, like you use proper indentation. Make sure that when you're reading it, it's easy to understand, it's easy to parse and all of that. I can't say that I've seen a ton of like super ugly SQL code recently. I know it's out there. And yeah, if you're writing ugly and bad SQL code, stop. Number 14, UML diagrams are highly overrated. Yeah, I would say, yeah, like in my career, I really haven't had to do that many UML diagrams. It can be helpful if you need to explain something to people outside of your team. It can be helpful if you're just trying to document some things of like, this is how like the big picture stuff works. For the most part, they're kind of a waste of time. So yeah, I would agree. Like it's not to say that I don't use them. They can definitely come in handy at times, but it's not something that I'm like doing like day in and day out is I guess what I would say. Number 15, readability is the most important aspect of your code. Yes. This is actually like, yeah, I agree with this one big time. So one thing that I have struggled with in the past is sometimes folks will want to like over optimize code and they'll want it to perform like blazing fast and be like the best performing thing ever. And then when you actually look at it and you try to use it, you're like, how does this even work? I don't know how to use it. And so if someone doesn't know how to use the thing, well, it's not going to get used. So even if it's the best performing thing out there, it doesn't matter. No one's going to use it if they don't know how to use it. Readability is a big one. And really like start off with like write something that is easy to understand, write something that you can come back to in 3 weeks, 6 weeks time, and you can understand what you were doing, and that is a huge benefit. From there, you can always like extract things out into like private functions and just like things where it's like, hey, just don't look at this. This function explains what it does, but the inner workings are going to be kind of confusing. If you want to get there, feel free to get there, but don't use that as like a starting point. 16, XML is highly overrated. Yeah, I'm gonna modernize this one just because this is coming from a like older article. I'm gonna say JSON is overrated. We use it in way too many places these days, when in reality, like we don't need to be. Hey Tina, can you go away? Thank you. Yeah, I would say like JSON is kind of the XML of like whatever, like 2013. Because at this point, like you can use just better things. Outside of JSON, like you can use like proto buffers, generate your code. You're all good to go. Both the server and the client know what they're doing. It can work more efficiently too because it's not serializing it to be human readable. So yeah, even though like this one XML is highly overrated, like yeah, it is, or maybe it's underrated at this point. I don't know, but JSON is like, I would say that is highly overrated. So number 17, software development is just a job. Yeah, so I think this goes back to like one of the first points that we talked about, where like if you, what was it, like programmers who don't code in their spare time will not be successful. Yeah. Yeah, software development is just a job. Let's just see like what they're kind of getting at though. So I enjoy software development a lot. I've written a blog for the last few years on the subject. I spend enough time on here to have 5,000 reputation points. They're talking about Stack Overflow. And I work in a startup doing typically 60-hour weeks for much less money than I could get as a contractor because the team is fantastic and the work is interesting. But in the grand scheme of things, it is just a job. It ranks in importance below many things such as family, my girlfriend, friends, happiness, etc. Yeah, so I think that's an important one because when you're getting into software development and you're talking to recruiters, you're talking to managers, what they sometimes are looking for is like, hey, do you just love code and like that's all you do? And so it can be kind of jarring, but yeah, like it is just a job. I've worked with plenty of really great people in my career, and I have left plenty of like perfectly fine companies in my career, just because it wasn't fulfilling the needs that I had at that time, given my career aspirations. And so it is really important to not get hung up on the fact that it is just a job. You can always get a new one. You can go somewhere else. If you're not enjoying the job, don't stay there. Like, I mean, talk to your manager, see if you can make it work. But if you're not feeling fulfilled, like just, you can go somewhere else, or you can go the other direction and just be like, hey, it really is just a job. I'm here for 40 hours, I'm out, and then I do things I really enjoy. So you can kind of make it like, you can interpret it a couple different ways, but yes, it is just a job. Number 18, if you're a developer, you should be able to write code. Yes, but I'm gonna read the description and then kind of disagree a bit, I think. I did quite a bit of interviewing last year, and for my part of the interview, I was supposed to test the way people thought and how they implemented simple to moderate algorithms on a whiteboard. I initially started with questions like, given that pi can be estimated using the function 4 times, my eyes are already glossing over. If you are a developer, you should be able to write code. You should be able to, talk in programmer type lingo during an interview. Ideally, you should be able to solve a problem during the interview, or many problems, but it is also on us as the interviewers to make sure that the problem that people are solving is ones that anyone who can do the job would solve. So I hate math. I cannot stand it. And so if an interviewer gave me a question where I need to, figure out the, pi approximation to like X decimal places, I don't know. Like, I don't do that in my day-to-day. If I had to, I would not be a programmer. And so I think those questions are pretty lazy. I think the good questions are more like you're trying to solve a problem and it's more focused on like a real world thing or something tangible that anyone can at least like pick up and understand. But in general, like, yes, programmers should be able to code. During an interview, they should be able to show that they know how to code. And so there's some different ways. Like if a candidate has a portfolio and they have a GitHub project that was worked on recently, I will usually talk about that as opposed to giving them a coding problem. I found that those problems don't really give me a lot of great information. They're not really things that I'm super pumped to talk about. And so, yeah, I agree with the premise, or I agree with the sentence. I don't think I agree with the premise because I think they're asking probably pretty bad interview questions. So number 19, design patterns are hurting good design more than they're helping it. Software design, especially good software design, is far too varied to be meaningfully captured in patterns, especially in the small number of patterns people can actually remember. And they're far too abstract for people to really remember more than a handful. So they're not helping much. And on the other hand, far too many people are becoming enamored with the concept and try to apply patterns everywhere. Usually in the resulting code, you can't find the actual design between all of the completely meaningless singletons and abstract factories. There's a lot going on there. And so I would say poor use of design patterns, it does hurt your code. And it hurts your overall design more than it's going to help it. But if you're using the design patterns well, it's going to help it. And the reason why is, let's say you're working on a team with more than one person and you need to convey like how you're solving the problem in a cohesive manner. Like you don't want one developer solving things this way, another developer solving things this way, and the new developer you just hired is going to solve things the way that they want to. You need some sort of cohesion because you need to make sure that the code just makes sense going across different files and things. Like the way that problems are solved, like they may be slightly different, but the design patterns themselves help out because you can use that as just a way of saying like at this layer of the application, this is roughly how things should be executed. And so an example of that would be if you're retrieving data, you probably want to have a repository pattern, and that repository pattern should be set up in a way where you can have a single interface for retrieving things, an interface for deleting things, for updating, for creating and all of that. Like that should be pretty much generic, and it should just be down to like what object types you're returning and all of that. That helps out in the code review process. Like you have a better idea of like, hey, it should be looking like this. I don't have to like try to understand exactly what's going on or like you don't have to like pick up a new pattern to understand what's going on. But on the other hand, if you're just using design patterns for the sake of using design patterns because you think the design pattern is necessary, don't do that. Because at that point, you're just kind of writing code that may not even be necessary. And so if you're doing that, avoid that. But if you're working on a team, you will end up needing to use design patterns. Like it'll just happen. And in general, for like an established project, it should already have those patterns set up, and it should just kind of be easy to just jump in and solve those problems. Number 20, and the last one, less code is better than more. If users say that's it and your work remains invisible, it's done. Glory can be found elsewhere. If you can solve a problem with less code, do it. We don't get paid by lines of code. And so really like, if you spend a day writing like 3 lines of code and it works exactly how it needs to and it's easy to understand, you succeeded. Like if you spent a day and you wrote like 3,000 lines of code and it's difficult to understand and it doesn't solve the problem, you failed. So yeah, it's not even like, yeah, if you can write less code, like there's a lot of benefits. Like one, less code means less bugs because there's less things that can go wrong. It's easy to review if you only have to like review a couple lines of code as opposed to a couple thousand lines of code. You can compartmentalize what you're trying to review in a quicker way. The review quality is probably going to be better. Outside of that, like less code, less stuff to test, like it's a win-win-win-win-win-win-win. Like, yeah, less code is better. So anyway, that is it for the controversial programming opinions. Thank you for watching this video. It was a slightly different one. So let me know what you thought of it in the comments below. And other than that, if you haven't subscribed already, be sure to subscribe and hit the like button while you're on the way down to hit the like button. And other than that, I will catch you in the next one.